Hi, my name is Laura Marie Coleman. Thanks for joining me for this video on thinking about the strategies that we use for addition and subtraction and wondering if the standard algorithm is always the best strategy once students learn it. We're going to specifically focus on grade 3 math. Our goals are going to be quickly review some of the various strategies for adding and subtracting and practice identifying the most efficient strategy by thinking about the numbers in a problem. So here's some of the strategies from grades 1 and 2 that students work within 100 that we're expanding in 3rd grade to larger numbers. When you take a look here on the top, you have an open number line, and then the next strategy that we see here is decomposing one addend to make an easier problem. Down here you have a place value representation. This strategy is a strategy that we use and call the standard algorithm. It's just drawn on a place value chart. So all three of these models really record the same strategy, just in different ways. This place value chart also has a little bit of a scaffold built in, is drawn like the base 10 block representation, so you can see the magnitude difference between hundreds, tens, and ones. You also might notice that I have students draw dots instead of squares for ones because it can be difficult to differentiate between the ones and the hundreds. This middle one on the bottom row is the standard algorithm thinking, but it's done with numbers written out in expanded form. You also might notice there's an extra step in here where I break apart or decompose 14 into 10 and 4, which helps me see when I add that I have 700 plus 100 that I can compose from the tens in the middle, plus 4 to get 804. This last one is the standard algorithm, or US standard algorithm for addition. You might notice that I use new groups below. This helps students see that when I add 7 ones plus 9 ones, I get 16 ones. I can see them right next to each other here. And that 16 ones is made of 1 10 and 6 ones. Same thing with the tens place. I have 3 tens plus 9 tens plus 1 more 10. Gives me 13 tens, which is made of 3 tens and 100. And I can see those 13 tens when I put them next to each other. So let's think about options. We talked about strategies. Now let's think about how do we choose an efficient strategy. So open number line is one that students use a lot in 2nd grade. They should be pretty comfortable with it. Same with place value units and thinking about decomposing a number by place value units and adding the like units together. And then we have the standard algorithm notation, which starts to develop in the end of 2nd grade. We continue to develop it into 3rd grade, and it's not actually a standard requiring students to be proficient with the US standard algorithm until 4th grade. So with this one, that open number line has a lot of steps on it. It could be helpful, but I also think that standard algorithm thinking, whether you do it with expanded form or standard form, is probably a more efficient way to think about this. This next problem, though, is interesting. Like the previous problem, has us renaming units in 2 place values. But when you look at the option of an open number line or decomposing an addend to make an easier problem, instead of being a multi-step problem with lots of regrouping, here I am breaking apart and going from 299 to 300 and then adding 536 all at once, and in 2 steps I can get my answer of 836. So in this problem, I would say either the open number line or the very similar thinking represented in decomposing an addend to make an easier problem is probably going to be the most efficient strategy. Now let's look at subtraction. We can also decompose in subtraction so that we can take from a part of the total and then add the 2 parts that are left. We also can count on an open number line. Likewise, you could count back too. Then we have 2 representations for very similar US standard algorithm thinking. We have expanded form, which I really like because it helps students preserve the fact that they took 100 from the hundreds place and brought it over to the tens place. And so when I add those 10 tens to 2 tens, I have 12 tens, or I can think about going from 20 to 120. Same thing in the ones place. I go from 7 ones, I bring that 10 over, and I have 10 plus 7, which is 17 ones. So this, again, very similar thinking, a little more abstract. Students sometimes lose those place value units and the meaning of what they're doing. This one, though, is pretty powerful. So in this strategy, it's called constant difference. I know that as long as I change both numbers the same amount, the difference will stay the same. So in this one, instead of having to do all this regrouping and renaming, I can just add 1 to both numbers and see that the difference between 538 and 300 is 238. So for this problem, I would say that the standard algorithm is by far the least efficient strategy. Decomposing to take from a friendly number, or counting on an open number line, or constant difference are all really efficient strategies that eliminate some of the opportunities for error that we would encounter in the US standard algorithm. In case you're wondering about constant difference, here's a picture of what it looks like if I think about 299 and 537 on the number line. I can maintain the distance between these 2 points if I move them both up 1 point on my number line. And because the distance stays the same, I can make these easier, friendlier numbers, and I can still subtract and find the difference. So just keep in mind that while proficiency with the US standard algorithm is a very important standard in grade 4, it is an important strategy for students to understand and be able to use efficiently. It is not the only strategy that students need, and it's really helpful to have other tools in your toolbox. Having that variety of strategies that you are proficient with and understand how they work gives you a sense of agency and control and power. Thanks for joining us, and look out more videos and resources on our website at pimaedu.com.